So we're going to skip all the pretty pictures. We are talking about probability. Now, probability is pretty much saying, what are your chances of this happening? What are your chances of getting a heads when you flip a coin? Now, when we talk about how many cards are there, if we have a deck of cards and we say, what is the probability that I'm going to pick a certain number of cards? Well, then your sample space is exactly how many cards there are. So how many cards are there in a deck of cards? 52, right? And just in case you're not quite sure what that means, you have a deck of cards, right? And in each deck of cards you have our diamonds, you have spades. I am definitely not very good at drawing. We have our clubs, and we have hearts. And in each of these are called suits. In each of these, we have numbers, right? We don't start on number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go to a jack, a queen, a king, and an ace. Way down here at the bottom. Now in each of these, we have these, right? Every single one of them. And if we add them all up, then we have 52 cards. So that means that our sample space here is 52, because that is everything that we could draw. All right. If you're doing a die, like a dice, you know, one of those things that look like that, and then they have the little dots on them, 1, 2, 3, and it kind of looks weird in the 3D, but I think you know what I mean. What would our sample space be for this? How many numbers are there? Well, there's 6, right? Because there's 6 sides to a dice. Well, at least on a 6-sided dice. That is our sample space. That's how many things that there are, how many opportunities for a different answer. Okay? How about if we flip a coin? How many sides are there on a coin? What our sample space would be. So we have our sample space, and here's our guy here. Obviously this is heads. So our sample space for that would be 2, right? There's 2 sides on the coin. So, how can the cards be grouped together? Well, let's look. We kind of grouped them together already, didn't we? We can group them together by hearts. We can group them together in their suits. We can group them together by numbers, because each one of them has the same numbers, right? We can group them together by face cards. Remember that these Jack, Queen, King are face cards because they actually have a face on them. So those are some different ways to group them together. Oh, and that answers our next question. What are the name of the face cards? Jack, Queen, and King, right? Now I'm going to run over there real fast and change my screen because I don't have a smart board. So just a second. It's beautiful. Okay. So these are kind of a lot of the same questions here. Let's bring them up. What is one way you can group the cards? If you were going to group a group of cards, a deck of cards, how would you group them? Well, let's say that we wanted to group them by suits. This is their suit. So how many are in each suit? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 in each suit. We could group them like that. We could group them by their numbers. Remember, I just am not filling these in all the way here. We could group them by numbers. How many would be in each number? Well, there's 4 2s. So we could group them, there's 4 in each of these, isn't there? So we could group them by number, or like the last question said, we could group them by face cards. Which, how many face cards are there? Well, 1, 2, 3. Apparently my thing's squeaky. And then there's 4 of these, so 3 times 4 is 12. All right. What is the name of one of the suits? This seemed to be interesting questions here. Name one of those. Heart, diamond, spade, and clubs. Okay, if you pick one card at random, do you have, I think that's supposed to be any chance of choosing any card? Yes or no? Well, let's see, somebody hands you a deck. Let's say Miss Vasquez she wants to do a magic trick. So she shuffles out the card and says, pick a card, any card. And you have to pick one. Do you have the same chance of picking any card? The answer is yes. Unless somebody rigs the deck, then you have the same chance of getting any one of those cards, right? So the answer is yes. What is the probability of choosing a heart? Now here's where we actually get into a little bit more of the probability. What is the probability of choosing a heart? So here we take the hearts. Now how many hearts are there? Well, we already have our number here. We have 13 hearts, right? Now we're going to put this number and say 13 out of, and then the denominator has to be the whole sample space. How many cards are there in the whole deck of cards? How many cards are in the whole deck of cards? 52. So you have 13 out of 52. Let's reduce this a little bit. Can we reduce it? Yes, we can. We can divide each side by 13. What is 13 divided by 13? 1. 13 divided, or 52 divided by 13, that is 4. So you have a 1 in 4 chance of drawing a heart. Okay, that's as far as we got in our class, so we will continue to do this again later. Let me know if you have any questions. If you have questions, you come to the office hours. All right, bye.